All right, next, here's the power of a quotient rule. So very similar. This time, if a and b are real numbers and n is non-negative, then and a non-negative integer, then if you have a over b or the quotient of a and b, right, to the nth power, then once again you can basically distribute that exponent to each of the bases inside, right, or each of the exponential expressions inside. And so remember that, there's an invisible one here, invisible one here. So essentially you're multiplying the outside exponent by the inside exponents. All right, so let's see some examples. So number 54. So I have y over 3, right? And so I can remember that each of those bases has an exponent. And so I'm just going to multiply the outside exponents by the inside exponents. So what I get is y to the 1 times 4 is 4. On the bottom I get 3. And then 4 times 1 is 4. Right? And so that's basically it. That's the power of a quotient rule. We still have some more work to do on this one, right? 3 to the 4th we can simplify. So 3 to the 4th is 81. And so that's our final answer. All right, so number 56. Same idea. So which one of these bases is missing an exponent? Looks like the 2. So what would that exponent be? That's right, it would be a 1. And so now we can distribute the outside exponents to the inside exponents. So I'm still going to have a w on top, still going to have a 2 on the bottom, but the exponents will change, right? 3 times 2 on top, going to be 6. 3 times 1 on the bottom is 3. So I have w to the 6 over 2 cubed. 2 cubed can be simplified. So 2 cubed is 8. So that's our final answer. All right, continuing on. So this negative 9, I'm going to think of it as, in parentheses because I want to make sure I include the negative there when I deal with the exponent. So that there's an invisible 1 there. And then t to the 5th in the bottom, that's fine. So I'm going to distribute, right, to all the inside exponents. So I have negative 9 to the 2nd power. 1 times 2 is 2. R to the 6th power. 3 times 2 is 6. And then t to the 10th power, right? 2 times 5 is 10. Okay, and then negative 9 squared, it's 81. And then everything else just comes on over. Okay, so that's how we do the power of a quotient rule. Number 6 is a little different, and I should have mentioned this before, but with any of these problems, we still want to observe order of operations, right? The order of operations, PEMDAS. So what I should have at least checked for, or at least mentioned before, is there anything we can do inside to simplify, right? And with these previous examples, there wasn't anything we could do inside. But on number 60, we do have some simplifying that we can do on inside the parentheses. So for example, here we have a y on top and a y on bottom, right? Can't do anything with 3 over 2, can't reduce that. There's no other z there, so the z is kind of on its own. But with the y's, we can use the quotient property. So let's do that. So I'm going to bring over the 3, and then with the y's, I'm going to end up with 1y, and I'm going to subtract the exponents. 8 minus 2 is 6. Okay, then on the bottom we have the 2 and the z. All right, and then we still have the 4th power on the outside, and now we can get ready to use the power of a quotient rule. So I have the outside exponent. I'm going to make sure that I identify all the exponents on the inside. Right, don't clump these together with the 6, right? We want to make sure that the 3 has its own exponent, right? And the 6 goes with just the y. And the 2 and the z on the bottom each have their own exponents. All right, so now we're going to basically distribute the outside exponent to the inside exponent. So we're still going to have all these bases, right? Leave room for the exponents, but now we're going to have new exponents. 4 times 1 is 4. 4 times 6 is 24. 4 times 1 is 4. And 4 times 1 is 4. So those are all our new exponents. And we can do some more simplifying with 3 to the 4th over 2 to the 4th. We can expand and evaluate those. So 3 to the 4th is 81. Y to the 24th can't be simplified. 2 to the 4th is 16. Z to the 4th can't be simplified. And so that's our final answer, right? Check to reduce. 81 over 16 can't be reduced. So that's as far as we can go.